With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello guys, today our question is which of the following limits tend to unity? A is limit extending to 0 sin tan x upon sin x. B is limit extending to pi by 2 sin cos x upon cos x. C is limit extending to 0 sin of e to the power of x minus 1 upon x. And D is limit extending to 0 under root of 1 plus x minus under root of 1 minus x upon x. So we can solve one by one and check which of the limits tends to 1. So limit extending to 0 sin tan x upon sin x. So see, when we place the limit, this is tan 0, that is 0, sin 0 is 0, and this is also 0, so this is 0 by 0 form. We can apply the L'Hopital's rule. So for that, differentiating this is cos of tan x into sec square x divided by cos x. So placing 0, this is sec square 0 is 1, cos 0 is 1, and cos of tan of 0. So this is cos of 0, and see, we know that cos of 0 is equal to pi by 2. So we can write 0 as cos inverse pi by 2. So we can replace this tan x by cos of cos inverse pi by 2 into 1. This is also 1. So this is equal to pi by 2. So the value of this limit is pi by 2. So first option is incorrect. Now we'll move on to option B. B option is sin cos x by cos x. Limit extending to pi by 2 sin cos x by cos x. See, this is cos pi by 2, that is 0, and cos pi by 2 is 0. So this is again 0 by 0 form. So this is equal to, see, we have a result that limit extending to 0 sin x upon x is 1, and here in our question x is replaced by cos x. So this is same as this expression, so this will also tends to 1 only. So the value of this limit is 1. Now we can go on to option C. Option C is limit extending to 0 sin e to the power of x minus 1 by x. Okay, so this is e to the power of 0, that is 1 minus 1, sin 0 is 0, and this is 0. So this is again 0 by 0 form. We can apply the L'Hopital's rule. So differentiating this is cos e to the power of x minus 1 into e to the power of x divided by 1. Placing the limit, this is equal to cos of, see, this is like e to the power of 0, that is 1 minus 1, that is 0. This is again 0, so we can write 0 as cos inverse pi by 2. So this is equal to pi by 2. Now D option, limit extending to 0 under root 1 plus x minus under root 1 minus x by x. So this is 1 minus 1 by 0. So this is again 0 by 0 form. We can apply the L'Hopital's rule. This is 1 by 2 under root of 1 plus x minus 1 upon 2 under root of 1 minus x by 1. So this is 1 by 2 common. 1 by under root 1 plus x minus 1 by under root 1 minus x into differentiation of 1 minus x, that is a minus 1. So this is 1 by 2, 1 by, sorry, and 1 by under root 1 plus x plus 1 by under root 1 minus x, which is equal to, placing the limit 0, that is 1 by 1 plus 1 by 1, that is 1 by 2 plus 1 by 2, which is equal to 1. So the value of the limit is 1 over here. and 1 over here. So our option B and D are the correct options. So the correct option for this question is option B and option D. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.